Hello everyone, in this video we are just going to build a LED dimmer with the help of variable resistor using Arduino UNO development board. Let's get started. So in the previous lecture, we just interfaced a variable resistor or potentiometer with the help of analog channels available in the Arduino UNO development board. And I hope you remember this program that we wrote in the previous lecture. This is the same program that we wrote, and in this we are just going to make some alterations for building the LED dimmer circuit. So this is the Arduino UNO development board, right? And we used the analog pin 0 for reading the voltage that is coming out of the variable resistor and digital pin 7 for connecting the LED. And now we are just going to use the same analog channel, but we will not be using the digital pin 7 for connecting the LED. Instead, we will be connecting the LED to digital pin 6, because you can see a negation symbol is given before several pins right over here. So these pins are compatible for PWM function other than the pins available in this row. So that is why we are using digital pin 6 instead of digital pin 7. Let me explain in detail about this while writing the program. So I am just going to connect the LED to the digital pin 6 of Arduino UNO, and I have configured the LED pin as output. I am not going to use the serial monitor, I am just deleting these. So I am keeping the step value right over here. So this step value will be having the values between 0 to 1023, that is the 2 to the power 10 value. So I am just going to turn on the LED with the help of a function called analog write LED, and this function receives second parameter as a particular value, that is an 8-bit value starting from 0 to 255. So based on this value, this pin will provide a PWM signal for varying the brightness of the LED. So for this, you can see we are receiving a value between 0 to 1023 here, but here you can see the value that can be provided is between 0 to 255. So we just want to map this step value that is available in the range between 0 to 1023 to the range 0 to 255. So for that we will be using a function called map in Arduino IDE. So this map function call is useful for mapping a particular range of data into another particular range of data. That is, let's take this example itself. I am just passing the step value as the first parameter, and following this first parameter it also receives 4 more parameters, that is the initial range of values at which the variable is ranging, that is 0, 1023. So here you can see this is the range of values at which the step value is available, and following that you just want to pass 2 more parameters to which you just want to map this values between 0 to 1023. So I just want to map this range to the range 0, 255. So that's it. You can see step value which is available between the range 0 to 1023 will be mapped to the range 0 to 255. So this function call is a return type function call. So I will call this with the variable called mapped value. I am just declaring this, and finally I am just going to pass this to the analog write second parameter, and you can see we are fetching the data from the A0 pin of the microcontroller Arduino UNO, and after that we are mapping that value between 0 to 1023 to the 0 to 255, which can be provided as a parameter to the analog write function call. We are doing this because we just want to pass that to the analog write function call, and based on the step value that we receive, the brightness of the LED will be varying. That is, if you decrease the step value by rotating the knob of the potentiometer in the anti-clockwise direction, the brightness will be decreased, and if you increase the step value by rotating the knob of the potentiometer in the clockwise direction, the brightness will be increased. So this is the logic. I'm just going to upload the program to the Arduino UNO development board. I'm just clicking on this upload button for uploading the sketch. Now build this circuit to see the output in the hardware. Now I'm just going to build the circuit for making the connection between 10K variable resistor or a potentiometer with the Arduino UNO development board. So this is the Arduino UNO development board, and this is the potentiometer already connected in the breadboard. So this rail over here, you can see this rail over here is internally sorted for the third pin of the potentiometer, and the second rail, that is this rail, is connected to the second pin, and this rail is commonly sorted to the first rail in our breadboard. So I will be just connecting this rail, that is the first rail, to the 5-volt pin of Arduino UNO. So this is the 5 volt. I am just connecting this to the 5 volt of Arduino UNO, and the second pin regarding the middle terminal of the variable resistor or potentiometer, I will be just connecting it to the analog pin 0 of Arduino UNO, that is this A0 pin, as per our circuit, right? So that is what we did in the program. And thirdly, the third pin of the variable resistor or potentiometer, I will be just making the connection between that pin to the ground of the Arduino UNO development board. So this is the ground. That's all about the connection. I will be just powering up this circuit with the help of USB port. So this is a ground rail, right? So this is a ground rail. As we discussed, this is commonly sorted to the ground of the Arduino UNO development board. So I will be connecting that rail to the cathode of the LED. And regarding the other end of the LED, that is the anode of the LED, I am just going to connect a 220 ohm resistor. And now, as per our schematic, I am just going to make the final connection, that is the other end of the resistor will be connected to the digital pin 6 of Arduino UNO. You can see I have connected the LED pin to the digital pin 6 of Arduino UNO. You can see this is the output that I got in my hardware. That is, initially the potentiometer is in extreme ground end, so the step value will be 0. And when I turn the potentiometer to the other extreme end, you can see the LED will be changing its brightness based on the rotation of the potentiometer. It keeps on increasing. So this is the maximum brightness of the LED. This is the output that I got in my hardware. See you in the next lecture. Thanks for watching. See you in the next lecture. Thanks for watching.